All right, everyone, I do want to take a look at this particular problem. I think one of the pre-calc classes got to it, one of them didn't. I just want to show you how I would approach this problem and then kind of explore an idea that one of the pre-calc classes had in class today. All right, so these problems are a little confusing at first. All right, so I was sensing about half of you were okay, and then half of you just really weren't getting it today, and that's okay. That's normal. All right, that's going to happen a lot as we move forward. All right, but we just got to practice. Don't get frustrated. You know, this stuff is hard. But we can definitely work through it, okay? So let me show you two ways to approach it, and then we'll take it from there. All right. So when I look at this, I think the easiest thing to do is to rewrite everything in terms of a base of 2, okay? Because I know that if I take the square root of this 4, I can get a 2. Get the little highlighter. Like I can take a square root there and get a 2. I can rewrite 8 as 2 cubed. So it looks like there is a connection as far as these bases and the numbers that I've been provided with rewriting them as a base of 2. All right. So basically these problems come down to rewriting something and then distributing through the exponent or factoring out of the exponent and then using that to rewrite something. All right. So it's just a lot of rewriting. So let's do this side in red. And then we'll do the other side in some other color. I don't know. All right. So I want to try to get these to have a base of 2. So I'm dealing with a 1/4, and I'm basically going to ignore the exponent for the moment because I'm interested in rewriting this to have a base of 2, and then, you know, we'll just simplify the exponents when we have to. All right. So let's see if we can get started. I'm going to show more steps than I typically do. So instead of 1/4, I'm just going to rewrite it as 2 squared because at least that I now have a base of 2. It's in the denominator, which I don't really want, so I got to deal with that in some way. But at least I have a 2 acting as a base somewhere in my problem, which I didn't have in the problem I was given. All right, so if I have it in the denominator and I want to flip it back up, all I'm going to do is rewrite this as 2 to the negative 2. And then everything else will just kind of stay, right? So basically ignore the exponent until we need to either distribute or factor something out from it. In this case, it appears that we're just going to distribute that negative 2, and we should be good to go. So we have 2 raised to the negative 2x minus 4. Is that right? Okay. And, all right, that's the left side. Now let's go over here. We'll do this one in blue. This one isn't as exciting here, so you can just rewrite 8 as 2 cubed. And then we'll deal with the exponent, so I'm just going to distribute that 3 through, which I think you guys are all okay with this, so this should be okay. All right, so this is what we ended up with. Now, the only way for these two sides of this equation to be equal is when they're raised to the same powers, right? We both have a base of 2. So if these are going to be equivalent, which I want them to be because it's an equation, then we're just going to set them equal. So we'll say negative 2x minus 4 is equal to 3x minus 12. And then we just kind of solve this. So we'll just add 2x to both sides. So we get 5x over here. Add 12. What are you going to get? 8. So, 8. So x equals 8 over 5. Okay. That's probably the most straightforward way to approach it, is turning each of them into a base of 2. All right, but the answer is 8 over 5. So I kind of want to explore another idea, another way to approach this. This is what the other class was doing. They didn't see it as rewriting bases of 2. Okay, they saw it as, well, if this is a base of 1/4, let's convert this into a base of 1/4. Okay, and that's kind of what we were working on, and we ran out of time. But I think it's an interesting idea. Let's see if we can make this work. So it appears if we're going to take this approach that this side is all set. Right, this side's good to go. So what are we going to do about the other side and converting this 8 to have a base of 1/4? We gotta think about this a little bit. So I don't know if I can't take the square root to get from 8 to a 4th. I can't cube anything or take the cube root. However, I guess I could write the 8 in terms of a base of 2 to get started. So 8 is just 2 cubed, so 3x minus 12 to kind of start. And then 2 into a 1/4. So what do I want to do? I'm trying to get that 2 to be a base of 1/4. That's what I want to end up with. So what would that power have to be? So 1/4 raised to what gives me 2? Is that negative half? So negative 1/2, so the negative would tell you to flip it, so you'd have the 4 in the numerator, and then the divided by 2 would tell you to take the square root. Yeah, so I think we're going to raise 1/4 to the negative 1/2 power, and then we can distribute that through. So it kind of looks like this. It's a little messy, but it's all valid. It all works. So then we're going to have 1/4 on this side, raised to negative 3x over 2 plus 6. Is that right? Yeah, I think that works. Okay. So 1/4 raised to x plus 2 on the left, and then 1/4 raised to that fractional exponent. All right, so then the concept is the same. We'll just set them equal, and then we'll see if we get the same answer. Hopefully we do. Otherwise, I have to start the video over. That would be terrible. All right. So I'm going to move over the 6. So what do you get? Negative 4 on this side. I got to move over this x right here. But we got to add the fractions. So it's like 2 over 2. So you got to subtract that. So is that negative 5 over 2? That's promising. Yeah, I think it works. So we're now going to multiply by the reciprocal. So we'll just do times negative 2 over 5 times negative 2 over 5. So on this side you get negative 8 over 5. No, positive 8 over 5, excuse me. Positive 8 over 5 is equal to x. Yeah, it works. Okay. So like I mentioned in class earlier today, there's a bunch of ways to do this. Okay, so as long as we're applying the laws and not violating any laws, you can approach these problems the way that you want to. All right. I know that these are a little bit confusing, and anytime that I show you something that doesn't have one exact way to do it, it's going to get a little more intense, right? Because there's different ways to approach it, and it's not like a set kind of ordered steps. Like it's not like step 1, step 2, step 3. They're all going to be a little different, right? Once we start talking about like